So R squared is based on the SSE and the ratio total, right? And the pseudo R square, I can give it to you. It's in. It's actually
Sure. Yeah. Look at me.
So this is based on the ratio of the likelihood between the estimated parameters, the model with the estimated parameters, and the null model, which is essentially just a intercept equation. And I can't remember offhand the exact equation that is used, but it's essentially the same thing. Well, not the same thing, but it reduces to the R square if you're using a linear model.
Okay. Well, that has to suit the sufficient,
Okay.
Unfortunately. But it's okay.
Okay.
Okay, now the last one is figure 3, where you look at the schedule, well, where you show there's no linear relationships, right? Find reproduction, this one.
Okay.
It's one of your slides.
Yeah. I think you designed it to produce the effect that you want, like the audience to have, no relationship.
Yes.
But I was wondering if you had just scatter plots of showing all the data on one hand, or box plots, instead of what you have here in terms of just a line and an error bar or something like that. What would it look like?
A mess.
Yeah.
It does look like a mess.
But I think what I find confusing about this graph too, you're putting too much information in each slot, because you're showing north and south. It would be better if they had been separated.
Okay.
Right? I mean, it's okay. Mess is good. It's a mess. It wants to be a mess. Let it be a mess.
Yeah.
But don't make it any messier than this, okay? Okay.
I have to be honest. I think this is cleaner than just using it.
Well, I don't see anything in it. And you're right. You have reduced the desired effect. But as a scientist, I was wondering, it's just too much at once. And it always makes a self-fulfilling prophecy. You want to create a mess? That's easy to do.
Okay.
But it's harder to demonstrate it.
Okay.
Yeah.
Yeah. Maybe a comparison would help.
Okay, thanks. Moving on.
Okay. Let's go back to that slide from the other data slide. Now, yes. So if we look at the standing problem, I'd like to ask you to speculate. What do you think of the possibility that what you're seeing at the northern sites in standing crop is a response to climate change?
As a response to climate change. It could be, but I think that this much of an increase over such a short period of time is too much. I think that Paul may have had it right with the impact of the two installation.
Right. Oh, yeah.
Yeah.
So, but could you test, could you use your model predictions to test that?
I could see how close they fit, but I don't know if that would prove anything one way or the other.
In your introduction to chapter 2, sort of paraphrasing, you say something that it is it's vitally important to identify whether the relationships of binary dynamics are related to climatic differences relative to species distribution. So I'm going to ask you a two-part question. One is to tell me what that means, and then the second one is just to sort of what you conclude about what you learned with that.
Okay. So, please repeat it.
So I'm paraphrasing sort of two sentences in that introduction. And it's something to the effect that it is vitally important to identify whether the relationship of climate dynamics are related to climatic differences relative to species distribution.
Okay, yeah, so I guess what I was getting at, in that is the idea of climatic optima. So the idea that each species will have an optimal range in which it can grow and survive. And I wanted to underscore how important it is to know what the relationship between the climate dynamics and that climatic optima, which will shift with climate change. And so if we understand what the relationship is between the optima and then we can understand how it's going to change with the climate. If that makes any more sense.
Maybe.
Okay. And then what I found with that, from that, regarding that, rather, I would say that we've kind of got an idea now of how they might work as a whole system, the production and mortality of roots, as opposed to trying to understand how general changes in climate will affect pine roots. We can look at it now in terms of how the climate will change within a given region, depending on where that region is in relation to the species climate optimum.
Okay, so in sort of searching for this optimum, you sort of have two sources of variation in the annual temperature.
Yes.
One is the regional one, and then the other one is the interantral variation.
Yes.
But is there anywhere in your analysis where you try to separate those two effects?
I did, when I was parameterizing the models, I did try to incorporate the affected region to see if the estimates differed between the regions, because it has been found that trees from different regions grow under different climate optimal. And I couldn't get the parameter estimates to show any significant difference between the regions, and so I took that as a sign that this may be sort of an overall thing, at least within the region that we looked at.
I guess one last question. And that is sort of in your equation for mortality, it's that great big long list of things multiplied by the standing crop. And so everything besides standing crop can be interpreted, or the final result of that can be interpreted as a relative mortality rate.
Yes.
But it's not possible to do that with the model for NPP.
Yes.
And so I guess I'm wondering whether there's alternatives to the way we model NPP.
There might be. The reason why I modeled MPP the way it was, part of it actually could be considered as a turnover. This on the right side there, the climatic effects. But in order to incorporate this density dependence for the production regarding the previous year's standing crop, I can't think of any way to make it easily into something that's that could be interpreted that way.
That's it.
Okay. Just to continue on that. So and I think I was spending time studying this whenever I sent you this one. So the climatic optima are left
Well, that was in regard to provenance trials, where trees taken from different regions across Canada, this was a Boston Fir provenance trial. The trees taken from different regions and then grown within a collective garden, a common garden experiment, they differed depending, their growth differed depending on the temperature. And so some of the provenances would grow very well at high temperatures and others would not. And so if that is something genetic in those trees, then this model would completely miss those differences in terms of optimal growth conditions. And so it's not perfect, but I think that it did a pretty good job. One thing I didn't mention in the presentation that is in the thesis in the manuscript is that the optimal climatic conditions that I found in terms of fine root stain crop agreed very closely with those that were found through observational studies on the species in general. One thing that I've even thought of doing is trying to make a species distribution map based on the fine root standing crop values, but that may or may not make sense.
Okay, general questions now. So what would you say is the main finding that you're contributing to science?
I think that it would be the predictions in terms of the future simulations. Those have never been done with fine roots on their own. So there have been simulations that tried to predict fine root growth that was always associated with the tree diameter or something like that. And so in this situation, I was able to predict something that has a pattern of fine root standing crop that has been known since the 80s, but no one had really explained how or why production or mortality would work together to produce those patterns.
If you were able to redo your project, what would be the main thing that you'd like to change?
How far back am I able to go in terms of do it? Like, if I could get the,
You answer the question the way you want. It's a general question. I'm just seeing what you have to say.
if I had all the time and money in the world, I would have all of the age classes replicated within multiple different climates, and cover the entire range of species, if that were possible. Yeah, that way I would be less concerned about having only older stands in northern sites and young stands in the southern sites.
And last question. So what is the main thing you think should be done next? What would you say to your supervisor? The next master's thesis, this is what should be focused based on your work.
Something other than fine roots.
Stick to it, okay.
Yeah. I think that if I were to give some advice in terms of looking at fine roots, I would say don't try to look at things linearly or continue with this method, because it's been 30 years now that people have been, and longer, that people have been trying to understand how climate is affecting it, and they keep coming up with different, depending on the study or the species or where it is, and so on. So.
But what specifically would you have the next group work on?
I would want them to work on another species doing the same kind of thing, to see if this model can be.
Generalized.
Yes.
Thank you.
All right.
Hang on. You want to jump in? I missed a member of the examining committee.
Well, so's Merritt.
He's not on the examining committee. He's on the advisory. I thought you guys were stacking the examining committee with all.
No, we have to decide who is going to ask questions, because we are particular.
Oh, okay. So
You're not on the examining committee, are you?
You're on either.
That's it?
You're not on the examining committee, you're on the advisory.
Oh,
I wait for the public to be called.
Okay, so sorry.
Okay, well, no, I'm not on the exam, I'm gonna keep quiet.
Oh, I
Now I'm not even sure why I showed up.
What a privilege.
I'll let you ask questions. Well, we should let-
Okay, I will not usurp my privilege here. Thank you, Mr. Chairman. Question, how long do your pine woods live?
How long? On average, that's a great question. I'll give you the simple answer.
Okay.
Around between 400 and 500 days.
Okay. I would like to turn your attention to this slide, where you show this north and the south. And you're looking at the standing crop and NPP and predicted, so your results.
Yeah.
And I challenge you to, oh no, that's not, it's all these.
Yeah, I split them up for the presentation.
Okay, well, here, to the benefit of everybody, I'm looking at the prediction of NPP, pine roots, mortality, pine roots, and standing crop. So the current situation, the status quo, basically, says in the south you're going to end up 5 units of pine roots standing crop, and your mortality would be 2.5 units. And so is the productivity.
Right.
Ergo, you actually tell us that the pine woods will live exactly how many years?
Well, it's hard because these are Monte Carlo simulations.
But that's fine. Let's see what the Monte Carlo suggestions tell you.
Yeah.
Face value, right
Yeah.
there.
Right. So, in each, at this point, you have a large amount of production, and
And mortality.
what's that?
And mortality.
Yes, but the mortality is in a different pattern from the production.
Sure.
So
Here we see mortality and productivity evening out to what? 2.5 units.
yeah,
Whereas the standing crop is 5.
right. And that would give essentially the standing crop is what remains before that equilibrium occurs.
That's right.
And then that would give a 1-year turnover rate, so about 365 days. So the simulations are lower, but quite similar, as far as I can tell.
Well, to make it more interesting, in the north, you have standing crop of, let's see, 6 at the end of 2100. But the productivity and mortality rates are just 1.
Yes.
So this suggests to me that your pine woods live about 6 years as compared to 2 years, north versus south. So they'll have greater longevity up in the north, according to your Monte Carlo simulations.
Right.
Is that fair?
I think so. I think that's what we found in the observations.
Now, do pine woods really live 6 years?
Some of them do. And there's a debate as to whether you can even characterize the entire population of pine roots using a single age distribution. They found that there's a certain population that appears to turn over rapidly and another that.
Okay. Anyway, so the other thing is that reading your thesis, I'm now thinking greenhouse, okay? And in greenhouse, you can make the pine woods anything you want to do. Change the fertilization system, the irrigation, the temperature, whatever, okay? And you can manipulate the shoot-root ratio, okay? So, and the interesting thing is that if you increase fertilizer, the shoot-root ratio becomes bigger.
Right.
And it's not desirable.
Right.
Okay. So, your model is really not cause and effect, it's simply empirical. If you know the climate variations, you get this. But what really is the cause and effect that determines what pine woods do?
That's a great question.
Yes.
That's something that I actually am thinking about doing for my PhD as well.
Yeah.
But yeah, that may be another thing that I would advise my advisors to talk to their next grad student to look into.
Fair enough. I'm done.
at a standard age of 0 and you grow them. And in each simulation, the climate changes annually as it would be expected to do as a result of climate change.
Yes.
And so there's two different, so that, and the starting point, you have a starting point for Southern New Brunswick and a starting point for Northern New Brunswick.
Right.
So, I guess I'm wondering whether you, asking you to speculate, if you always, for each one of those years with climate change, you'd always estimate the standard crop production rate of a mature state.
Yeah, I did do that to sort of to see for my own. Didn't make it into the paper or anything, but you actually see, as opposed to like this slide, where you see those separating out right around this age, they begin to separate out very rapidly. And a mature stand under the warmest scenario would, at that point, be essentially 0 after 89 years of growth. And I don't know if that's a part of trying to simulate starting in the middle of a stand age, or if that's an actual artifact of the climate change.
Okay, so the results depend strong a lot on the fact that the stand development is involved in that.
Yes, yes. Yeah, so that initial rise is important to the simulation.
So what you're talking about is not simply a response to climate change, it's a response to the combination of climate change and stand development.
Yes.
Yeah, actually, it's the question I was going to ask.
You find that.
Okay. I've got two quick questions.
Okay.
First one is, did your model deal at all with the anticipated distribution of precipitation under climate change scenarios, where they're expecting higher amount, but like more flashy, like bigger events, like maybe droughtier than the rain?
No, I just flattened it out into a single. Yeah.
You think that would make a difference?
I think yes, definitely would.
And then just with your explained variance, was that kind of in the range of what you were hoping for, or were you think they were low? Or I'm asking as a social scientist, we get pretty excited if we get R squared. I'm curious.
I really have nothing to base it on, I guess. I know there have been some models that I've read, and they were generally less than 50%. I was pleased with that, especially the standard crop.
Okay. So, anybody else? Further questions?
So you said this is the first time this was explored, right?
Yeah.
All right, good, cool. Yeah. How far back was data collected? What year? How far back?
Well, it was collected from 1998, basically until 2013. But each site was not collected necessarily in the same years.
All right. I have not looked at climate data, but I do subscribe to all of this. If I were to just pay attention to the Canadians on the bus who are never really happy with the weather, are we not in a really chaotic, weather is chaotic to begin with, but yet we have a very well-behaved model and prediction of what would happen for, how long is it, 100 and something years?
Yeah, 89.
So if we were to take the worst outcome for ecology and humanity, we should talk about that, maybe not in your thesis, but somewhere appropriate. Talk about that alongside given our current behavior, oil and deforestation, how affects things on the planet. Take your worst outcome, put it up next to what a whole big chaotic scenario might be.
Sure.
Should we communicate something towards ecology and humanity?
That's something that I've been kind of wrestling with,
Yeah.
because on the one hand, you see these massive declines in the standing crop in the southern region.
Mhm.
But on the other hand, the northern region is predicted under at least moderate warming to increase in standing crop. And and also turnover in the northern region it's lower when it's cooler and it increases as it warms up, meaning more carbon being cycled through those roots. And so I can't decide myself whether I believe that the net effect in terms of carbon cycling through climate roots will be what that effect will be as a result of climate change. And I think that it needs a lot more studies before we can really say anything clear about that.
Would you feel like you'd need to model it before you say anything about that?
I think so.
All right. Is that just you, or that's how it should be?
That's me.
Okay.
And I think that should be.
Thank you.
Any other questions? I think I feel coming out.
I'll ask the question now. Go back to your simulation slide.
One of these?
Well, like the standing crop one there. Okay. You know, as Mike pointed out, you know, the simulation confounds climate and age, you know, just like your data confounds climate and age. What do you think would happen if you started a new stand at, say, 2040 under the changed climate?
Under the
You know,
Take the
for all
extremes.
your different, you know, climate changes, you know, at 2040, you've got some predicted new climate rate.
Right.
And you started a stand, you know, then, and, you know, what if you started a stand at 2060? And
Right.
would that give you a better measure of what climate change is going to do to fine roots than what's going to happen in this one stand that started at 2010?
Yeah, and I think probably what I would expect, I think that would definitely help to understand better how they work together. But I would expect that because the turnover is greater under the warmer stands, that you would have smaller and smaller of those initial peaks. Because all of these, I mean, the change in the climate from here to here is very little between the scenarios. And so maybe if you start one here, then the no change scenario would go up to that same height, whereas the warmest scenario would maybe go 2, 3/4 of that.
Yeah, it would be interesting to do, to see what, because so much of that is driven by the standing crop, because, you know, that just
Right.
literally gets fed in there, and
Yeah, that would be definitely something we could do. Look at.
Can I ask you a question? Continuing along the same line, you could say that essentially, if you think about it logically, the difference between one standing crop and the next one is the net difference between productivity and mortality.
Yes.
So how come that you don't see any differences in productivity and mortality that are really visible, but we see those really declining standing crops?
Yeah, again, it's because it's a Monte Carlo simulation, these are sort of the average values. So each individual simulation may not correspond to the overall averaging of the values. And it's such a hairy mess that it may be that, you know, the warmest scenario is slightly higher than the production, but not necessarily enough to really show here.
If you go for a second to your slide that shows the age classes out of the different stands. Yeah. So if we understand that each cluster of these graphs represents a different stand in which observations began from point zero. That means essentially you didn't have at the beginning any roots, and you were looking at newborn roots over time. So remember from our looking at the longevity in young stands, longevity is really long. So the turnover rates are really slow.
Right.
So that's maybe why you have such a build-up of standing crop and such a build-up of mortality over time. But then it would be wise to look maybe at the sort of middle-aged stands, see whether that changes because the turnover is faster. And maybe there is again slower turnover in the end.